Hello and welcome. We'll continue the phrase-add patterns with the range sum query immutable, which is quite a mouthful. So we are given an integer array of nums and we want to calculate the sum of elements, the sum of the elements of nums between the given indices. And we can see that we are given the number -2, 0, 3, -5, 2, no, -5, 2, and -1. And the first query that we're given is to find the sum between the index 0 and index 2. And we can see that -2 plus 0 plus 3 is indeed 3 minus 2, 1, which we can see here. And we can also see from the second problem, the second query rather, index 2 up to index 5, and if we sum all this, it is indeed -1. So basically that's the problem that we want to solve. Now let's give ourselves more room. So we are given the numbers -2, 0, 3, -5, 2, and -1. And basically the first intuitive approach you might think is that when we are given index 0 up to 2, we can just basically loop from index 0 up to 2, and if we're given from index 2 to 5, we can just loop and find all the numbers or the sum of the numbers from index 2 to 5. And basically if we're given from index 0 up to index 5, we can just run another loop again. Now this is the most intuitive approach, but you can see that this gets repetitive a bit. For instance, if we're looking for the sum of index 0 to 2, we already have this, and remember that this problem says that we'll be given multiple queries at a time. Is there any way we can do this efficiently? This is going to run in linear time. For each query is a linear time operation and constant space. Linear time because we are basically just looping through the given number, and since the number can go as large as the entire number, like case of 0 to 5, 0 to 5, now basically we can go from the beginning of the array to the end of the array. So that's a linear time operation, and we're not using any extra memory, right? So that's constant space. But we have to know that we can handle this problem. Is set to handle multiple queries, so we have to think of ways whereby we can do it better. And we can say that if we have computed the sum from index 0 to index 2, then we are going from index 0 to index 5. Basically, we are recomputing it from the beginning again. Is there no way where we could have stored or have access to the sum from index 0 to index 2 rather than starting all over again when we have this problem? And yes, there is a better way, and that better way is the prefix sum. So basically the prefix sum means that we, at every index, and this is the second approach, by the way, the prefix sum. And prefix sum just basically mean previous sum. It means that for every index, right, we are going to store the previous sum at every index. So basically this is the first index, right? The previous sum from the previous sum of all of the numbers before index 0, we don't have any previous sum. So basically this is 0 because there is no number existing before this first number. So this is going to be 0, right? Then we move over to the second index, and the previous sum before the first index is basically just this first number, and we save it here. Now we move to the second index, the third number, and the previous sum is -2 plus 0. It is still -2. Basically there is nothing to sum it up with. And then we move on to the fourth index. Now let me just put this disclaimer here so it is a bit easier to remember. So basically this is the third index, and what is the sum of all the previous numbers before the third index? This is just 3 minus 2. This is 1. Next we move to the fourth index, and basically the sum before all of this fourth index is going to be minus 5 plus 1 is going to be minus 4. And then we move over to this one, and the sum of all the numbers before minus 5 is going to be 2 minus 4, that's minus 2. Now, our prefix sum is going to have an extra number to accommodate for the sum of this last number, right? Because basically at this point we are getting the sum of all the numbers before. But what about this number? We've not added it to a sum, so we have to accommodate for that. And we're basically going to say that, okay, minus 2 minus 1, this is going to be minus 3. Now this is what is called a prefix sum. At every index, we are getting the sum of all the numbers before that index. We are not including that number, right? Minus 2 does not have any number, so this prefix sum, there is basically nothing to sum, so that is 0. 0, which is at our second index, the only number before it is minus 2. Minus 2 plus nothing is minus 2. 3, right? The sum of all the numbers before index 2 is minus 2 plus 0, that's minus 2. The sum of all the numbers before index 3, 3 plus minus 2, and so on and so forth. Now, how does this help us? This helps us in that whenever we have a query of, find the sum of the numbers ranging from index 0 to index 2, basically, what is the sum? And we can just look at, okay, the sum at index 2 is going to be here, right? Because we know that this sum at index 2 does not include the number at index 2. Basically, we are computing that number at this. We do not include the sum of 3 at this. So for every right number, for our rightmost number, we are going to increment it by 1, because we can see from our array that there was an increment, right? So if we are being asked for the sum of the number from index 0 to index 2, basically we are going from, okay, so what is the sum at index 2? It is 1, right? Minus 0. And we can see that this is 1, like it's giving a sample input. And then basically we're asking again that, okay, what is the sum between index 0 and index 5? And we know that the sum at index 5 is going to be index 5 plus 1. Plus 1 includes the value at index 5. This only includes the number before index 5, but plus 1 includes, you have to look at this index plus 1 because we've incremented the array, right? So this is going to be minus 3 minus, what do we have at index 0, 0, and this is basically minus 3. Now, why are we minusing it? We're minusing it because we already have the grand sum at the rightmost and we have the grand sum at the leftmost. So if we take it away, basically we're just saying that, okay, what is the difference between this? And that's going to give us the exact number. We don't have to loop over every operation. We don't have to loop over all of the operations anymore because we already have the sum. And that is the prefix sum approach. We're going to be writing the code for the two, and then you can just compare and see how it is. Right, so the first approach is where we are just basically doing the normal looping through the intuitive approach, right? We have to declare this sum so that we can have access to it here, and then we're just going to return the sum of the index at the leftmost up onto the rightmost. So this is just basically a Python operation. I'm not sure if this sum exists in other languages, but if it does, we're just looking for the sum ranging from the number at the left up to the number at the right? And this is just the basic intuitive approach. If your language doesn't have any inbuilt sum function, then that means you would have to use the normal for loop to traverse from the leftmost index to the rightmost index, and we can see that this works, right? But since we want to how can we make this more efficient? We can make this more efficient by first finding the prefix sum. So at the first index, we know that no sum exists yet, so it's just going to be 0, right? And we're now going to run through all of the elements in the sum, and then we're in the norms array, and we are going to append, right? We're going to append the last element in the array plus the current norm. So basically this is saying that if we have let's go back to our example. We have 0, we have 3, we have -5, we have 2, right? So what this is saying, that self the norms, the first index is 0. Now we are looping through this entire array, and we are saying, okay, what is the last element in the array? 0. Does the current number, this is +2, this is -2, and then our prefix sum is going to look like this. We have 0 first. After the loop, we have -2. Then we run the loop again. And what is the last element? -2 plus the current element now is 0. So it's going to be 0 plus minus, which is -2. Basically, the prefix sum which is showed in the code walkthrough. Now, after we have done this, we can now compute the sum, which is just going to be as simple as saying, since we already have the prefix sum at each level, so what we're doing now is we're just going to say that the leftmost element, right, we're returning the rightmost element +1. Don't forget the +1, since we're increasing our array, minus the leftmost, the element that is at the left of this new prefix sum, and we're taking it away from the element that is at the right of this prefix sum. So this is just the code. As you can see, is pretty straightforward, and we're going to run this, and you can see that it even runs faster than the intuitive approach. I hope this was helpful. Please subscribe, it supports the channel, and I'll see you on the next video. Bye.